Wish you all a warm welcome to our workshop, and let's dive in. Let's make the most of this great opportunity to learn from each other. Thank you for being here. So let's get started with our first speaker, who will be hopefully sharing their screen.
Hello, Elena, can you hear me?
Loud and clear, Laurent.
Yes, and can you see the slides?
Yes.
Yes?
Yes, indeed.
Okay, so thank you for joining today, and thank you for inviting me to do this introduction on a very important topic, which is the flexibility into the pan-European system. I'm going to present today through two perspectives. One is the SmartEN perspective, which is the European Demand Response Association, composed of basically the leading technology provider for flexibility devices, but as well as for aggregator in Europe. And where we are working together in defining certain policy direction, as well on certain technical elements related to in particular to integration and data exchange. And I'm in charge of the digital committee of SmartEN. But in reality, I am also the CEO of Decibel in Europe. This is my core activity. And so Decibel is a member of SmartEN. And so we play the role of chair of the digital committee into the association, and I'm part of the board of SmartEN. So I would like to introduce a few elements to this presentation, which is basically a kind of a status report of where we think flexibility is at in Europe, and what we hope will happen through the next regulatory deployment related to the drafting of the flexibility code by the TSOs and DSOs, as well as the next electricity market designs, which is currently under negotiation between the authorities of the commissions and member states. So basically, we are in an environment where the type of flexibility is rapidly changing into the system. And what is really new as compared to the past is the very rapid introduction of flexibility at the consumer level behind the meter, both in terms of integrating electrical vehicle, 60 million in 2030 in Europe, large majority of charging happening in homes, so the vehicle being at standstill during a lot of hours in the nights and over the weekends, and representing a significant impact on family revenues. So basically, the smart charging of these vehicles are important in terms of benefit to end users. On the other side, you see the rapid introduction of solar PV, rooftop PV in particular, as a target to decarbonize the pan-European system. Currently, it's around 7 million homes being equipped with the PV, and the target is really to accelerate and reach probably over 40 million homes. And this is really accelerated through the current crisis because of the high energy prices. And what is really new into the current context is that the amount of congestion happening into the network at the low voltage is such that now this PV is in many countries largely introduced with storage, standalone storage, and that as well introduced new flexibility opportunity into the consumer environment. So really the basically combination of these two elements is changing the landscape of what is the flexibility available into the system, really going to the lower end. And I should have added to this slide all what's happening with the heat pump and the decarbonization of heat, which is another third element of this equation. So overall, what you are seeing is progressively the homes being rather inflexible or having less than 1 kilowatt flexibility on average, moving towards a situation where you've got over 5 to 10 kilowatt per home of flexibility, which is, if you aggregate this, a significant opportunity in Europe. In the same time, we see consumer having different behaviors, different approach related to tariff. Of course, the energy crisis has raised a lot of concern related to the bill and basically whether people should better use flat tariffs or real-time tariffs, while trying to make link with basically the personal implication into the climate change, carbon footprint reductions, and so on. But also the fact that nowadays every device is into the home come as a connected device, as an home IoT device, and basically there are new opportunity for automating the end-to-end control of this device through the flexibility market and the real-time market. Or even go one step further, is even become as a home self-resilient environment in case some significant event happen onto the grids in terms of brownouts and so on. That's new topics like vehicle to home, vehicle to grid. So what we really see happening, and we've asked, I would say, DNV to produce a study last year. If you go to our SmartEN website, you're going to see a deep analysis on basically the value of flexibility at the pan-European level, is that flexibility is going to come as available asset into the network. Probably over 50 to 60% of that flexibility is going to come from distributed assets, from homes, from residential, from consumer. And what is really new is that this flexibility is coming as a connected device, which itself is not provided by the aggregator or the retailer, but it is purchased directly by the consumers as a connected device. So really that is raising new topics, new discussion related to connecting digitally these resources, hence all our work onto the digital committee, but also basically how to release the data out of these resources, where the Data Act has just finalized by the legislation as is representing, I would say, a step forward into, I would say, forcing a certain level of data exchange coming from these devices, hence the data space. So what we think is that it has become really crucial to rethink the entire flexibility framework as a whole, because currently regulations are still too shy, I would say, on flexibility. You see on the left part the SmartEN report dated from 2022, analyzing which are the markets which are the most favorable to flexibility across Europe in terms of regulation. Apologies, I have some work around me, so it's a bit of noisy environment. So sorry if there is a bit of background noise. So you see on that map that there's still a lot of red and orange color, and especially I would say if we zoom down to cases of home and residential environments, it would probably be all orange and red, because most of the markets are not favoring today flexibility from these lower assets level. So what we think is really crucial to move forward is to rethink this consumer empowerment, consumer participation on one side, how to automate, how to interact, how to maximize this participation. And really here, the consumer is not a grid operator, is not an energy manager. It should come as a plug and play and easy to use device. What comes clear is the smart meter of the DSO is an important building block for the settlement of this transaction, but is by far not enough to be able to manage the needed real-time information. At the second step is the recognition that there are a lot of development around energy communities, and these developments are more and more related to congestion in the distribution grids. And so what we think at this local DSO level, we need to rethink how to favor emergence of a non-firm connection when there are a high level of congestion in grid areas, like what we observe right now in countries like Holland. And so that this requires to rethink how to combine and maximize the stacking of various services, from non-firm connection services to the DSO, into wholesale trading, intraday, up to ancillary service trading and so on. So we think the level of the community is a very important level to engage consumer and to facilitate adoption of consumer of new flexible behaviors. The third element is really to unlock demand-side resource in wholesale and auxiliary service market. I already mentioned this. None of these markets, almost in Europe, currently are favorable to distributed assets. And once again, there are various reasons behind that. One of them is largely related to how we calculate baselines and we settle transactions related to these distributed assets, which are based on all methods, very much statistically based, but which really do not reflect the quality of the response of these assets to this price signal, but also enable these assets to benefit from capacity remuneration, as an example. So basically, paying for availability as what we pay for power plant availability. And also very important, because the Commission is considering new renewable support scheme and bilateral agreements between renewable plants and I would say large consumers. We think that the same should also be developed for distributed assets. So in a nutshell, to enable consumer to source their energy with priority from cheap renewable from these contracts and basically manage their flexibility according to these contracts through the intraday markets and ancillary services. So we think these are very important elements into the future electricity market design. These are step change. The current regulations are not fit for purpose. So that's why we are spending so much time right now into the flexibility code discussion. And associated to the flexibility code, not to forget, is the fact that we need to progress into the past clean energy package regulation developments, where I'm sure everyone of you know that the clean energy package is mandating the development of a network code by TSOs and DSOs, so ENSOE and the DSO Association, where basically, which is aiming at redefining basically the core concept related to flexibility, whether it is flexibility related to intraday markets, balancing ancillary services down to DSO congestions. So that's the important element. I think, Elena, you also touched on another very important element, which is a data element and what happens with the Data Act and so on. And that the fact that fundamentally, bottom-up all connected devices are going to be forced to exchange certain sets of data with their users. And so basically open new access to data to consumer. The known case is the data related to state of charge of an electrical vehicle, as an example where now EV manufacturers are obliged to share this information to consumers so that they can themselves decide to share it with other service provider. And that brings really this notion of data space, where a data space is becoming a crucial environment for enabling consumer to take back control of the data, to benchmark basically their all associated settlement, the benefit which they can get from flexibility offers. But they also allow new data exchange, which needs to become more interoperable, and our industry needs to go towards further interoperability. If you're interested by that topic, I suggest you go on our website. We've produced a white paper just before the summer where we are proposing steps toward interoperability, trying to stop all the effort of fragmenting so many protocol standards and so on, and really focusing onto reference architecture and standards and making sure that they themselves work. So we hope that the data space is going to be a kind of an environment where all this should be fertilized so that we can really manage data access as easily as possible through the cloud. We can get a plug-and-play interoperable device from heat pumps installed by an installer up to the consumer, up to the flexibility service provider, aiming at trading into various markets almost automatically. And last but not least, of course, all of this needs to be cyber secure because a lot of this energy data is private. And I would say a lot of this data exchange is to be managed with consent and with full protection of consumers. So that's where we are today. So we think that it really requires the development of new approaches and so on. And just to come back on what we are doing on decibel, that's more for making the link with future projects. We are launching a new generation home energy station, which we think will become a default interface in homes to integrate PV, car bidirectional charging, and battery storage. And what's unique with this device, it's going to plug and play with energy data space using IEC standards, and will allow consumer to decide the service providers with whom they have the best advantage to trade and manage flexibility with. So that's just an example of what we think is the future for this flexibility in Europe. So I'm very happy to respond to questions, if any, and thanks again for inviting us for this presentation.
Thank you.
Sorry for the background noise.
Thank you very much. I didn't have any issue. Your presentation was very engaging. I think it was a very good introduction into the topic that we would be discussing today. So thank you very much for that. I would like to invite everyone to post their questions in the chat. I will read them out loud. We can ask all of our presenters today to give a comment. So let's say I see at the moment the first question posted in the chat, which is related to the introduced concept of data spaces. I would like to, Diogo is asking this question from Portugal. Diogo, perhaps we can save your question for later, because Professor Monti will also be expanding a little bit more the topic of data spaces. And I think the question is linking data spaces and flexibility services with interoperability, which again will be addressed throughout the presentation a little bit later. So we won't forget about it, but I propose that both Laurent and Antonello then answer this question later. If anyone else has specifically questions about other topics that Laurent presented, please post them right now. I would like to use the opportunity, since let's say we can discuss interoperability for sure. We'll have very interesting business cases presented and discussed today, but it's when we are talking flexibility as a new era of energy transition in Europe, we have to mention the hurdles posed by current regulatory framework. You touched upon that, and I know you are involved in drafting of the network code for flexibility. So could you tell us a little bit, how is it going? How is it progressing right now? You're on mute. You're mute.
Thank you, Elena, for this interesting question. I think they are, first of all, just to be clear, I'm not representing SmartEN into this debate, but Solar Power Europe, because we are both legs in SmartEN and Solar Power Europe, but we are more a supplier of hardware. So we thought that our positioning was closer to Solar Power Europe onto this specific case. And we are part of the drafting team on behalf of Solar Power Europe, which we think is important because, as what I was saying, rooftop solar is going to be introduced as a major development in Europe. And future flexibility need to be thought in the context of self-consumption communities, and so on. So what we currently see is that there is a document, a drafting document on the table, which has been a lot of work has been done by TSOs and DSOs in view of basically the framework guideline, so in a way the direction given by ACER with the regulator. Although a lot of work has been doing, we kind of remain frustrated with what exists today. To be very transparent, we think it's a very conventional way of seeing this flexibility market. It does not really address the issue which distributed energy resource behind the meter in residential home have to face. And here we are talking about level playing participation of these resources versus other assets into the markets. And we are also a bit disappointed by the fact that this code is for the moment very country specific and left too much focus onto a local country development in a way, which we can understand to a certain extent for certain products, because certain grids have specificities from that point of view, but which is really not meaningful for when you are looking at DERs like heat pumps, cars, and so on, where the same DER exists across Europe. So if we are not achieving a certain level of harmonization of data exchange, data interfaces, and lower the bar of integrating these devices into the markets and this flexibility, we are not going to make the case. And there is really a lot of money on the table. We calculated in 2035, this would represent 2.57 billion euros saved per year, this flexibility on the peak generation costs across Europe. So this is absolutely fundamental for Europe to find a suitable flexibility framework. But the current document on the table are not yet there. And we hope that basically we will go into a more ambitious development in the coming weeks. It's hard to say how far it's going to go for the moment. We have provided input. It's not clear what inputs are going to be used for consultation and so on.
Thank you very much. Now, I have to be mindful of the time and leave enough space for other presenters to continue. We will try to address some of the most interesting questions today. If there are any other pointers, we look forward to answering them. That's why we're asking everyone to post their contacts in the chat. So let us proceed with the next presenter on the agenda, and we look forward to other questions in the chat.
Okay, I guess this is my turn. Is that correct?
Sure, of course, and then we should follow up with Camilla and also ebalance Georgios with the actual two projects presenting now. So Anto, please make an introduction, and we'll follow with Camilla's presentation then.
Okay, thank you. Hope you can see my slides at this point. So my name is Antonello Monti. I'm professor in WTH Aachen, and also I'm a scientist at Fraunhofer FIT. And today I'm here because of my role in the ETIP-SNET. It was already anticipated by Elena, and I will tell you what the work in ETIP-SNET has to do right now with the element of flexibility. Very, very briefly in the introduction about the ETIP-SNET. So it's ETIP-SNET stands for European Technology Innovation Platform Smart Energy Systems. It's a platform that is an open platform that involves stakeholders from all over Europe, and as I say, particularly for industry. And through this platform, we had the possibility to prepare position and policy papers. They are developed in cooperation with the European Commission. There is a way then to build opinion at European level that can drive also the policy. Specifically, the working group 4 deals with the digitalization and customer engagement. Elena is the chair, and myself, together with Miguel Angel Sanchez-Fournier, are serving as vice chair. There are 3 activities currently going on, and what is interesting, all of them have somehow to do with the topic of today. The first one, which I will discuss more in detail, is a policy paper on data space for energy. The second one is the Task Force 2, dealing with the playbook on customer engagement. And of course, this is directly related. There is no flexibility without customer engagement. The third is a brand new activity that I will just briefly introduce, that is a position paper on digital skills. Again, even here, this is a key topic, because when we refer to digital skills, we are not talking only about academics, as you could imagine from my background, but it's actually the complete value chain that requires an upgrade of skills for digitalization. Why is then the topic energy data space so central? There are two topics that are currently at the center of attention for the European Commission. On one hand, grid management, general goal, system safety and reliability, and to facilitate this task through digitalization and remote control of components, there is a need of reliable and quick exchange of large amount of data, and that's mostly involving, on one hand, the grid operator, but on the other hand, the provider of data that could be connected to flexibility services and then customers. And the other aspect is sector coupling. The goal is increase efficiency of the control, but the coupling element again brings to link into other sector, and the easiest example is transportation, then electric vehicles. And this brings new challenges from a data perspective because we are dealing with heterogeneous data, so maybe standards which are not typical of the electrical sector. So data space is there as a concept to ensure a fair, regulated, and efficient data exchange to facilitate the data exchange we need for the different application. The connection, so if we look at the two topics in relation to flexibility, in the grid management, flexibility is a key asset for the grid management today. And the more we have penetration removed, the more we will need flexibility. And that brings a challenge because we have to establish basically two types of connections. On one end, the flexibility is establishing the need of more communication between DSO and TSO. But at the end, also as Laurent previously clearly put on the table, the link of flexibility provider, which means prosumers or aggregators. The sector coupling is not disconnected because a lot of the flexibility will not come from internal of the electricity domain. And that's where the data exchange is necessary and also brings the necessity to link to stakeholders which are not typically part of the ecosystem. What's the scope of the work in the ETIP-SNET policy paper? The policy paper should first of all make an assessment of the current status of data space, and understanding what is critical in terms of policy and regulation so that we can come to a deployment in Europe. We are not dealing with specific element of technology, so a specific implementation, while then is an agnostic type of analysis. And there is also the need to capture lesson learned from as a sector because energy is not front runner in this respect. And then with this exercise, we want to identify, perform a gap analysis and understand the move forward. This will bring us at the end to a roadmap. So what we have to consider to really focus on the scope of this paper is the timeline. What the Commission is hoping to learn from this paper is a very short time frame type of scenario to understand where are the highest chance to have a data space live and operating in Europe as soon as possible. As I will show you later, also in another slide, there is in parallel activity of research in terms of innovation actions, but their time frame is a little bit longer, being research project. They are bringing new technology for data space, but then that means the application can be within 4 or 5 years from now, and that's not the current agenda of the European Commission. I would like to stress that ETIP-SNET didn't start from scratch, but there were 2 important papers before that you can also check to have build your background on data space. One was developed by the CSA OpenDI, and another one was the work performed by the IoTI. Both of them reported some very relevant documents that are very good insight on data space. The topic is also discussed in the data management working group in Bridge, but in that case, we don't have a specific publication that I can give you to point. As I mentioned, this is a complex ecosystem of interactions there, and that is also bringing the background of the work at ETIP-SNET. You see ETIP-SNET here on the bottom, because a lot of input and experience is coming from the research project which are running right now, that you see here on the left, the share, data seller, EDI, Omega X, and synergies. Even if, as I say, they are developing a little bit medium term, maybe technologies are not immediate application. They have a lot of contact with real opportunities of data. So thanks to the cooperation with the NAT coordination action, which is INTNET, this is channeling to the ETIP-SNET a lot of information. Other important point, and the exchange with the International Data Space Association, because there where the standard for data space have been already defined. So we build on solid ground. That's where we learn from other sectors. And there is also, I'd like to mention, the Data Space Support Center, which is bridging the gap between energy and other domains. The project cluster is trying already to build common ground, which is also relevant for the paper. I want to enter in the details here of the goals, but it's important that not typically in many other calls, those projects work very closely together. This will allow us, for example, in terms of practical implementation, to have next year some minimum value product in which some of the technology of data space will be trialed. And that will be trialed in a way that is interoperable among all the projects, which is an early results, not typical of innovation action that I would like to stress. But
sorry, I would just like to interrupt you briefly here, just because of the time, and I know you are approaching the end of the presentation, which was very engaging. I would believe this particular slide I would let you introduce briefly. Is it correct to, let's say, assume that the use cases that you are presenting here are in a way the next step following the original flexibility use cases that may have come out of the projects such as XPlex and ebalance-plus that will be presenting the outcomes today?
Yeah, this emerging use cases, as I call it here, these are the results of one of the activity in ETIP-SNET, which has been a industry poll, which we collected the opinion of industry, not of the research project. Is the other side of this work. And you can see here the grid flexibility is one of the categories of use cases identified, and within the more details, two different use cases really match in the direction of flexibility. So that this link between data space and flexibility is very strong, and it is emerging as one of the priority for the possibility, as I say, to have data space in action very soon. There are some challenges and policies, and for the sake of time, I will just leave it here on the screen, and you can have the slide. And what is important is the timeline. By next week, we will have the first version that will be released to the European Commission, and then this will become public, and there will be possibility in public presentation to have interaction with ETIP-SNET if you have suggestions to improve this report. The other activity I briefly mentioned already, why are critical and why there is a link also in terms of flexibility. And so in summary, I would like to remark our data space are a key asset for the application of flexibility, but we need customers and we need to have the proper level of knowledge to make it possible at every level. Thank you. And I'm, of course, open for questions.
Thank you. Thank you. I hope this was also an invitation to some of the people contributing who are not just coming from research organizations, but also from the industry that constitutes majority of the ETIP-SNET to join the projects and to collaborate on this. This is exactly the tool that gives the floor to make impact on what is driven by European policies. So thank you very much for the presentation. I would just leave time for only one question, so we have enough time for ebalance-plus and Xflex presentations. That question was, how can we overcome the API protection that the majority of the appliances have? This limits the flexibility services to be provided to the users. And Laurent made a brief comment that the Data Act is responding to this, which is forcing a certain level of interoperability, such as data charge for electric vehicles. But perhaps, Anto, you can make just one brief comment about that before we give the floor to Camilla.
Yeah, what I would like to second to something Laurent already said. One of the key development that is coming from the projects and also from the collaboration with the international data space is the definition of interoperable data space connectors. Because this, when we have a standard, then we can go back to industry and say this has to be included. And even if there are different type of connectors, they are being all developed starting from the IDSA approach, which make them all interoperable. So when we have a framework of interoperable way to exchange data in a secure way with data space, then we have something that can be enforced also by regulation so that we can open up this possibility.
Thank you. This was insightful. It's I would say it's a top-down answer to a bottom-up challenges. For sure sounds simpler giving it as an answer than actually implementing it in practice. But this is why we have so many innovators here presenting today. And I'm very much looking forward to hearing from our two project presenters. I think it's very important to continue innovation work in projects, but what is valuable is not trying to reinvent the wheel, but learn from other projects that came out sometimes with, I would say, new or even challenging results based on the assumptions that we start all projects with. So hereby I would like to present Camilla Neumann, who will be presenting Xflex project, and Camilla will address the business models, how to quantify them in today's presentation, and some of the main outcomes from the Xflex today. Thank you, Camilla.
Thank you, Elena. Are you able to see my presentation now?
Yes.
Perfect. Yeah, so I'm really happy to be here today and to tell you a little bit of what we've learned as part of Xflex regarding business models, but also replicability of the demo sites. And I would like to start off by giving a short overview of the Xflex project. So as part of these projects, we've been working together with 11 other partners from 6 EU countries. The project started in 2019 and ends at the end of this month. We received funding of 7.3 million euros from the European Commission. And the overall aim of Xflex was to develop tools that enable and facilitate the use of flexibility in the power system. And this is with the aim to increase the stability and security of supply in general, but also as part of Xflex, especially in extreme weather conditions. As part of this project, we had 4 different demonstration sites, and I'm going to introduce those quickly because we also build our business cases around them. So the first demo site is Raune, which is an industrial city in Slovenia. And on one of the industrial sites, they installed a really big boiler, and the aim was to make use of the flexibilities provided by this boiler and able to support the local grid. The other demo site in Slovenia is Luce, which is a rural village and with a really weak grid connection. So the population of this village, they are really interested in having their own electricity supply. So they installed several PV units. They also have a community battery, and they created a local energy community. And as part of XFlex, we wanted to test how this local flexibility can be used and valorized. Then we have a demo site in Greece called Xanthi, and here a microgrid is with different storage solutions is used to support the overall DSO grid. And especially in cases with extreme weather events. And then the last demo site is Albena in Bulgaria, which is a hotel resort. And as part of this hotel resort, they have a lot of different boilers, and they increase the controllability of these boilers in order to provide flexibilities. So that's a short recap of the demo sites and the project in general. So we can now dive. I can change the slide. Okay. So what were the revenue streams we considered? So the ones that are marked with the red circle are the ones we did quantitative calculations for. So this mostly referred to the balancing market revenues, as this is a market that can at the moment actually be used for offering flexibilities, even though we had some issues with the minimum capacity for some of the demo sites. We also calculated the use case for the hotel resort in Bulgaria, where they reduced the curtailments due to the use of flexibilities. And they also applied an optimized charging algorithm for the boilers in order to make savings on their electricity bill. The way we made those calculations is either based on market data, so regarding balancing market prices, and further simulations done by the project partners. So I will start now with the first business use case that we calculated. That was for Raune, the industrial site in Slovenia, where a boiler of 5 megawatt was installed. And what we included for costs are the investment costs for the boiler, the operation and maintenance costs, as well as the XFlex licenses for the tools that are needed in order to control the boiler optimally. For the revenues, these flexibilities were offered on the MFR market. So we had a look at the year before what were the prices back then and applied those prices. And we assumed that we were able to offer this flexibility for 8,760 hours per year, and that it's 16 hours per year activated. This activation was really hard for us to estimate because I think it could go in both directions. But in general, this generated revenues of 213,000 euros per year. And based on these assumptions, this led to an IRR of 19% and a payback period of 7 years. It should be considered that if the heat that was generated by the boiler could be sold afterward, this could even be increased. However, we only activate the boiler 16 hours per year, so therefore the increase wouldn't be significant. What should be considered in this case as a barrier could be that there are really high upfront investment costs for the electrolyte boiler. So another case we looked at was in Luce, this rural village, and they also offered flexibilities to the DSO, but on the AFR market, we included the same costs, but this time we looked at a community battery and how much flexibility this battery could provide. And what we saw is that in this case, it's really the costs of the battery is really significant in defining if there is a business case or not. What we see is if the battery costs are at 1,200 euros per kilowatt hours, we get an internal rate of return of approximately 13%, while if these costs can be reduced, the IRR increases to 56%. And therefore, we had a payback period of 2 to 7 years. And then the last case where we're offering flexibilities to the TSO was for the demo in Albena, where we used the boilers, as I mentioned before, but they also had an on-site battery as well as the biogas plant that we could use to offer flexibilities. For this demo site, it's really specific to mention that we did not include any investment costs, but we only included the costs for better controllability, because those boilers are going to be in place anyway. Through Xflex, they were only able to control them in a way that we were able to offer the flexibilities. And based on this assumption that we do not include any investment costs, we had very high returns on investment and a very short payback period of 2 years. We also looked at the case where one could think that maybe a hotel resort would like to buy a battery for solely offering flexibility service to the TSO, but the use case turned out not to be profitable. So now we are looking a bit more into the use of flexibilities on an internal perspective. So using the flexibility according to the day-ahead market prices, for example, we looked at one boiler for Albena, and we saw that revenues of about 6,700 euros per year can be achieved. And again, since we only include conversion costs, this leads to a very high IRR and a very short payback period. And the last case that I would like to present today is to use flexibility to avoid curtailment. As part of this hotel resort, they installed several PV units, so they have a lot of PV. However, they are not allowed to feed excess PV electricity into the grid. So in winter, when the hotels are not open, they usually have to turn off some of the PV units. However, due to the flexibilities of these technologies, they were able to reduce this curtailment, which would lead to revenues of 31,000 euros per year, and also a very high net present value, as well as internal rate of return and a very short payback period, also considering only the costs to increase controllability. So those are the cases that we calculated for the Xflex project. And I think what it shows is that while the markets might not really be ready at the moment to offer these flexibilities, in the future, there could really be valuable business cases for several markets for external and internal optimization. Now I would like to jump in a bit of a different direction and say a little bit about the replication potential we identified for the Xflex demo sites. So where do we see the opportunities? I think other hotels were really interested in the results of this project. We held a workshop and they really showed interest in doing similar or offering similar services. Other industries with commercial boilers could also be interested, or battery owners. There were some integration issues, but they were able to be resolved in the end. The demo set also mentioned that they were lacking trained personnel. And we had a regulatory barrier because in the beginning, the minimum capacity to offer flexibilities to the TSO and the MFR market was 5 megawatts. And this was not able to be reached by Albena. However, they changed it to 1 megawatt, I think in the last year. So now this is not a barrier anymore. For Raune, we identified similar industrial zones as potential replication sites. And it should be mentioned that while this boiler installed in Raune is quite big, the solution could also be scaled down, and this might make it more likely for wider adoption. We had some similar barriers regarding the integration and also some knowledge obstacles. And as I mentioned before, also very high investment costs. And then for the last two demo sites, for Xanthi, it was mentioned that while it is hard to employ new technologies for the entire grid, it might be easier to have some smaller solutions, such as for fraud detection, and apply those first before then coming up with medium or bigger size solutions. For the Greek demo site, we also had an issue regarding the lack of data availability and that there is no framework for local flexibility markets at the moment. For Luce, I think this is a really nice example for other towns with weak grid connections and a high RES penetration. But as well, we had some knowledge issues. And there's also a lack of a regulatory framework. And it was mentioned that as long as batteries come with a really high cost, it might be more valuable to have grid reinforcements instead of using flexibilities. I think this sums up the main conclusions that we took out of the entire XFlex project regarding business models. And I'm happy to answer your questions.
Thank you, Camilla, for this very interesting presentation. Personally, my takeaway from this was how unexpectedly good payback times you experienced in very different demo sites. You had energy community, you had a hotel chain, so very diverse types of stakeholders, though this project is not going all the way down to the smart meter of the end consumer. So I would say that's probably the next level and next obstacle to tackle. But for sure, I think the figures that you have demonstrated, even without potential synergies with, let's say, district heating, for example, these IRR figures and these payback times are very attractive for any kind of investors. And for sure, the obstacle of high upfront cost is, let's say, on the regulatory bodies and financial institutions to understand and better tackle. But these figures do come very well into the business model. So thank you very much for the presentation. I don't know if anyone else has any other questions to add? Among other panelists as well. If not, we will revert in the end with questions to all of the presenters today. And I would like to give the floor to presentation of ebalance-plus.
Hello, everyone. I'm Georgios Stravopodis, an innovation and exploitation analyst from the European Science Communication Institute. I'm now sharing my screen. You're about to be seeing my first slide, and please confirm.
Yes.
All right, thank you very much. Well, our project is called ebalance-plus, and it's almost a 4-year research and innovation project towards its completion, with a goal to create solutions for energy flexibility, mainly distribution grids. It is funded from the EU's Horizon 2020 program, and among the 15 participants, ESCI is responsible for communication, dissemination, and exploitation of project results. A practice in the exploitation of such projects is to identify the key exploitable results. In ebalance-plus, we have 8 in total, the first 7 being marketable ones. Some of the key exploitable results are jointly owned by the partners that produce them. In the links that you see here in the slide, you can find more information about the ones that have been published in the Horizon Results platform. In order to commercially exploit this care, I will use this term in abbreviation of the key exploitable results, we have to develop business models. A core activity in this exercise is to identify the customers and users for this care and create the value propositions for them. We identified 7 user customer classes for the balance care, and we estimated that the highest impact will be on distribution system operators, aggregators and suppliers, and large consumers. We developed 2 categories of business models for the demo sites, as specific care would be demonstrated and for specific user customers, and business models for energy flexibility and mainly on the demand side. For each category, we employed a different methodology based on the project's objectives and progress. Our demo sites, 4 in total. In actual, there is also a 5th in-lab demo site in Germany, I see here my colleague Christoph in the participants. Apologies for this, for not putting also assigning them up there, Christoph, which are located in Denmark, France, Italy, and Spain, and have two common user types. The large consumer type, due to the university campuses and the collection of summer houses in Denmark, and the residential consumer type, since students reside in these campuses for long periods of time. So do the guests in the summer houses. The other two users are the grid operator in the Italian demo and the EV charging point operator in the Spanish demo. We developed the business models using the well-adopted business model canvas that, although its shortcomings, is still a powerful strategy tool. In this slide, we present as an example the grid operator business model. You don't need to focus on the business model elements, which are detailed. We just want to emphasize that for each value proposition, and there can be multiple due to the project's nature, we quantify their impact through selected KPIs. In this model, mainly legal and technical ones were chosen.
Okay.
Now for the energy flexibility models, we wanted to focus mainly on its demand side, where the main actors are grid operators, energy utilities or retailers, and consumers and prosumers. The most common form of demand side flexibility is demand response. This can be either implicit, based on price signals, or explicit, which is incentive based, and prosumers get paid for it. In our methodology, our intention was to create a blueprint business model canvas for demand-side flexibility that can be employed to produce variations of such business models, either for implicit, explicit, or mixed demand response. This is the result for the blueprint we wanted to create. I would also like to comment here that we have not yet actual figures from the demo sites, since they are now have started the operation. Now, based on the previous blueprint, we derived 4 demand-side flexibility business models. In the first one, the energy retailer sends price signals to consumers for peak saving or load shifting in exchange for lower bills. In the second one, the aggregators bid the flexibility from customer resorted to markets, and the customers receive direct payments. In the third one, the aggregator bids the electric vehicles flexibility or sends price signals for charging in off-peak hours. This is a mixed demand response scheme, both implicit and explicit. And the final one is where the aggregator provides non-frequency ancillary services to local flexibility markets operated by DSOs. These markets, as previous presenters have said, do not yet exist or are mature in the European landscape. The first model seems to be the simplest and most dominant so far. It also seems that the aggregator is the entity to bring the flexibility in most cases in the market, but an examination of their market positioning shows that the energy retailer has already the needed customer base, and it just needs the technology and a business model pivot to differentiate from the competition and add new lines of revenue. On the other hand, the aggregator has already the technology, but possibly lacks the retail's customer base. So, in our opinion, for technology providers, partnering with a retailer seems the best strategy. Now, as far as replicability, replicability of innovative technologies, solutions, and business models is a major issue, as well as their scalability, since in most cases they are mainly demonstrated in specific environments, and their application in other environments has a high risk, high possibility of failure. The Bridge Task Force has proposed recommendations on the subject, and as far as care replicability, it's proposed to employ quantifiable KPIs. In eBalance, we took a slightly different approach on this. Since a business model may employ more than one care, we linked the KPIs with the value propositions we created. We showed earlier in the grid operator business model that how we linked the value propositions of this business model to specific KPIs. And furthermore, we introduced a novel concept on replicability assessment via an indicator, which is a result of the care involvement in its business model and its obstacles to innovation. Which is the rationale behind this? The rationale is that the involvement of several innovative care in combination with high barriers to innovation makes a business model more difficult to replicate. Thus, a low score means higher replicability, and a high score means lower replicability. In the same context, a local country in most cases, a business model replicability indicator can be employed by multiplying the care involvement in the business model's country application with a care country obstacles to innovation. Now let's see the steps to apply this methodology. First of all, you need to do analysis of obstacle to innovation per care. In our project, and my colleague Mara, who is also here in the participants, performed such an obstacle to innovation analysis using 4 classes of obstacles: institutional, coordination, infrastructural, technological, and capabilities. Of course, if someone else tries this methodology, can use its own classes of obstacles to innovation. What we did next is to rate these classes of obstacles per care. Our advice is to use a range of 1 to 10. We did not do this from the beginning, but this is one of the lessons learned. And then create scores for each care and its category obstacle. The average result can be either can either have equal or different weights per obstacle category. The optional steps here is, if you want to do a country assessment of the replicability, is to do for the same obstacles analysis per country now, and calculate the same average score per care that you have different weights that can be applied per country. The next step is to rate the care involvement in each business model that you have developed. For example, let's say that for business model X, we have N care. Then you rate how much each care is involved. We did this by doing a survey among the project partners. And the results we got for the 4 demo site business models, here you see the table with the colors, are for the demo sites. And the coloring scale here indicates what? The red color in Care 7 grid management units in demo site business model 3, which is the grid operator business model, has the highest score. And this is also true, since you need grid management units to enable this business model.
Is that a good or a bad thing, being red?
It is. It's neither good or bad. It just indicates how much this care is involved in this business model.
Mm-hmm.
If it is red, you can use the opposite coloring scale to use the higher score with green. Here it shows that it's highly involved, this Care 7, in this business model. And then this is the final result table where we have done this multiplication that you see here. I don't mind here the formulas. It's very easy to actually to implement if you understand the rationale. And we have the total sums here, total score that you see in the yellow shape. And as I said earlier, the lowest results means the most replicable business model. Here the result is that the demo site business model 0 is the most replicable, which is the residential consumers. Okay, and as far as the country application, if you see at the second row of this color table again, demo site business model 0, you see that Denmark, DK, has 57.66, is the lowest score, which means it's the most replicable business model in this country, in our case, Denmark. And the final conclusions, the shortcomings of this approach. This method was devised in the last stages of the project implementation, so it was not included from the start in the original exploitation methodology for better integration. And we have not used efficient granularity in the assessment of obstacles to innovation or in other scores, because it took place a lot earlier. and for most, it hasn't yet been reviewed by peers. That's all from us. I hope you find the presentation interesting, and we're open for questions.
Thank you very much for your presentation. It's very interesting. It's a pity you didn't start measuring these things or actually applying them already. I think this is the kind of tool you can use even in proposal preparation stage, let alone later when you're developing.
Yes, I agree.
Developing tools and solutions. I think the outcomes are very, very different. And I think if we applied this kind of methodology across horizontally most of the flexibility and energy data spaces projects, we would have very different conclusions. You had the highest replicability potential, for example, with the residential demo site, while Xplex project previously had some of the best outcomes with industrial sites. So I would say it's a very interesting outcome, very interesting results.
I would like to note here that the results, the actual scores were pretty close to each other. Deviations from each demo site were about, I'd say, an average of 5 to 10%. So this is not a very good, I would say, conclusion that the residential is by far the most replicable. It's just for the specific approach and the method we used and its specificities showed this. Perhaps in other projects will also be most replicable for the industrial consumers.
I think for sure something that the Commission has in their mind when they are publishing these innovation calls is to understand the exploitation potential. And this certainly puts certain expectations or numbers in terms of where it would be most meaningful to replicate the tools that each project is developing. So it's very valuable, not just as part of ebalance-plus, but I think overall for projects. So thank you for that. And I had one more question, but now I realize that your project is still in implementation. So your demo sites are installed, they're operating, but you don't yet have, let's say, final calculations regarding revenue streams. And that was my second question in mind. So perhaps also Camilla, if she's still with us, she can give an additional comment. I'm curious, since we're talking business models today and replication, and you already have some numbers and outcomes, can you share which of the approaches or revenue streams are rather short-term and which could be considered rather long-term to achieve? So if Camilla or...
Yeah,
hi.
Hi. So what we observed is that everything internal, so using flexibilities according to price signals, that goes quite quickly and is already really easy to do. Everything that it goes to a market is way more difficult, especially on a local level, because there are no regulations yet on a local.
Camilla, I think we lost you.
You're muted.
Yeah, I don't know what happened. But everything on the market, existing market, is a bit more difficult. But then if we go on the local markets, that seems where to draw the line, where we could not really do anything within Xplex because there are no regulations yet in place. I think some of the technology is still missing, and there are a lot of different end consumers that you have to consider. So this is where we see really difficulties.
Thank you. Georgios, do you have anything to add?
I agree that we're in a very difficult place, that we have the technologies, we're very eager, we have good innovators, but unfortunately the environmental and market conditions are not, regulatory and market conditions are not yet met to start producing numbers that will show from an economic standpoint of view that these technologies and business models are about to bring value to markets and society in general.
In relation to that, I would like to ask one more question to all of the presenters today, perhaps to reflect on it. So having heard today's revenue streams, business models, discussions, what would you say are the critical steps to unlock flexibility at consumer level? So question to all, Laurent, Anto, Georgios, Camilla.
Well, since I have my microphone open, I would say decentralization, decentralization, decentralization. I think that the more consumers are have their own photovoltaic systems and batteries for self-consumption and using digital platforms and tools and data spaces, of course, we will create this reach this energy transition the sooner that is needed, and also in this context that we're facing this energy crisis.
Yes, I can go and continue, Elena, if you want. I think maybe the project, it's very interesting outcome first. So congratulations for the people who work on this project. I think what is striking is, well, the case of consumer at residential level has not been fully taken care of for the moment, which is not a surprise, is always the most difficult part. So on that specific segment is really about accessing to data. You mentioned it in the Greek case. I think we see it everywhere, but there are actually other barriers related to baselines and so on. What I would also like to say is the speed to what TSOs and DSO are moving into that domain is for the moment still not very fast, probably due to being conscious of the risks, complexity of developments and so on. And we very often see that there are either no system at all or the current balancing systems and so on is not done for aggregating lower resources. I remind, I think in several countries still the threshold for aggregating into balancing market is over 10 megawatt, I think. And so that there is a lot of work to do into updating the backend system and bringing the TSO and DSO into a real operational stage.
I will like to add two more points. I would say one, simplification, because at the end, in my view, one of the major barriers is the whole process is, from a simple customer perspective, extremely complex and difficult. And this is, I believe, one of the big barriers. And the second is to really reach a European level interoperability, because as many points was mentioned, different country, different regulation, different interface, this is not acceptable, let's say, if you want to speed up.
I don't know if you're reading the comments. There's a comment from Krzysztof Piotrowski about interoperability and transparency, and his additional comment about previous question on APIs was that an even more low-level approach is to create agreements with manufacturers as initiated by the Commission and realized by the JRC in case of home appliances in a form of code of conduct that manufacturers can sign and follow. By that, the given devices are set to be compliant, and then they should follow some common approach towards using the flexibility they offer, which is a very interesting remark. I don't know if anyone else wanted to add something. One more, I would say, wrap-up question. We still have time. But one more wrap-up question. We talked a lot about interoperability, certainly the key. We can observe as we go one level down towards the end customer and prosumer level at the low voltage, we have to talk about the yin and yang of the flexibility story, meaning not just interoperable devices within households, but people themselves and their behavior. And we're seeing emerging trend in a combination of SSH sciences, nudging, behavioral analysis to get people to participate, not just switch off their oven or shift charging of their vehicle to other hours, but build programs that develop a sense of community for electricity, heating sharing, and development of joint digital skills. Anto, you mentioned a little bit about this initiative within ETIP-SNET, but certainly we combine not just 2, but 3 challenging topics in order to promote flexibility further towards the end consumers. We need interoperability and transparency in institutional level. Then we need the citizen engagement in a meaningful way, because we have very different participatory models. And finally, digital skills are not to be underestimated. I think this is one outcome that we have also observed, perhaps not so much, but still, even with industrial stakeholders. So please, if you have any other comments, add them. If there's anything else, sorry, I was on mute. If there's anything else I didn't ask you, you still wanted to add during today's workshop, please give your final comments or words.
Yeah, maybe on my side, one element which I would like to highlight is really this community element. What you say is, I fully agree with this view, and we tend to see at community and as a very technical animal in a way. In reality, it's more a behavioral community, in my view, where consumers are coming together to help each other and play a certain role towards climate change and others. And this is definitely a very interesting vehicle to help accelerate adoption, understanding of flexibility, and so on. And on the top of that, what I would like to say is also a lot of DER, as what presented in the introduction, are coming now as automated flexibility DER. And so it's going to be much less trouble and constraint to people when you have a standalone battery or a bidirectional charger, because it's going to automate the entire process. So I think the way we see flexibility is going to change a lot in the future, but still there are fundamental challenges on interoperability on one side and on stacking revenues from community savings up to ancillary services and so on.
Maybe my last remark on the topic of digital skills, because I think what we are seeing, at least also starting already from the academic level, contrary to the intuition, there isn't a boom of interest in energy. The number of people in Germany registering for a program in electrical engineering, forget energy, is going down. Well, we need more people, and that's happening at every level. Starting from installer to academics, we don't have enough people. This is, to me, one of the biggest danger, because we develop this fantastic technology and then nobody can put it in place. And this, to me, it's a serious risk.
Not to mention, if you have heard recent Kadri Simpson's speech about how we need to still continue investing in grids, we have a massive brain drain of good quality engineers going away from grid operation jobs towards installation of solar panels and more attractive. Even within this shrinking digital skills market of the energy domain, we have a lot of lacking skills when it comes to how to resolve the issues with congestion, how to resolve all of the complexities still coming up that cannot simply be solved by, I would say, aligning manufacturers to connect under the same rules. So thank you all for very valuable and interesting presentations. There was a question on whether it would be possible to share the presenter slides. We will be sharing all of the presentations, and hopefully we will also post the entire workshop on YouTube channels for everyone else. And I know quite a few people who couldn't join us today, but were genuinely interested in the topic. So thank you all, And I look forward to meeting you soon.